Hello mathematicians, here's the video for home connections 135 and 136. Name two fractions that are equivalent to 2/3. To find an equivalent fraction, multiply the numerator and denominator by the same number. You can multiply the numerator and denominator by 100 over 100. But because we have to draw, that would be crazy to have to split each section into 100 pieces. So my suggestion would be to choose something really simple. For example, if we split each of the three sections in half, that would be multiplying the numerator and denominator by 2. We made the sections half as big, which means we have to shade in twice as many, and then it will be equivalent. 4 out of 6. You could really do anything, but my guess is a lot of you will do similar numbers as I do, because choosing something easy is a great idea. Okay, I'm going to multiply by maybe 3 over 3. You could multiply by 4 over 4. If I multiply the numerator and denominator by 3, that's making each section 1/3 as big, which means I need to shade in 3 times as many. So all of your shaded sections should look equivalent, exactly the same. And I shaded in 6 out of 9. You don't have to have exactly the same numbers as I did, but choosing something super easy like 2 over 2 or 3 over 3 or 4 over 4 is probably the best idea. Okay, some equivalent fractions to 3/4. Again, choosing something really simple like maybe these 4 sections, again, splitting them in half. They are half as big, so I need to shade in twice as many. So instead of shading in 3, I'm going to shade in 6. And then those shaded sections look equivalent and are equivalent. 6 out of 8. 3/4 multiplied by 2 over 2 is 6/8. That's just an example. There's lots of possibilities. Maybe multiply by 4 over 4. So each of these 4 sections, I'm going to shade, let's see, there's a lot of ways to do it. I'm going to cut them in half first. And then I'm going to cut those halves in half. So that way there are 4 sections in each section. That makes sense? So each section is 1/4 as big, so I need to shade in 4 times as many in order for the shaded sections to be equivalent. So 3/4, if I multiply the top by 4 and the bottom by 4, and that matches my picture. 12 out of 16 are shaded. Rewrite 2/3 and 3/4 with a common denominator. Common means the same, right? What do you have in common with your friend? What do you have the same as your friend? So I see 2/3 and 3/4. I know I can make a 3 into 12, and I can make a 4 into 12. So that would be my suggestion. If I multiply the bottom by 4 in order to make 12, I got to multiply the top by 4. 2/3 is the same thing as 8/12. And if I multiply the bottom by 3 to make 12, I need to multiply the top by 3. 3/4 is the same as 9/12. So I can compare them. I know that 2/3, which is 8/12, I know that that is less than 3/4 or 9/12, right? 9/12 is bigger than 8/12. All right, moving on to page 136. Sketch and name two fractions that are equivalent to 1/4. Exactly the same as what we just did. So 1/4, I am going to, let's see, how about, just to keep everything simple, multiply the numerator and denominator by 2, which really means make the sections half as big, but then you have to shade in twice as many. So instead of shading in 1 section, I'm shading in 2 sections. 2 out of 8. 2/8 is equivalent to 1/4. And again, just to keep it easy, I would choose a nice easy number. So of these 4 sections, maybe I'll split each of those sections and make them 1/3 as big, which means I need to shade in 3 times as many. So instead of shading in 1, I'm going to shade in 3. So 1/4 is the same as 3/12. Okay? And all those shaded sections should look equivalent. Number 6, a fraction equivalent to 3/10. So I think, again, to keep things nice and simple, I'm going to double the top and double the bottom, which means each section is half as big, which means I need to shade in twice as many, and that will keep the fraction equivalent. So instead of shading in 3, I'm going to shade 6, because 3/10 is the same as 6/20. Your answers could be different than mine, but these are just some nice, easy examples. Rewrite 1/4 and 3/10 with a common denominator. Remember, common means that they are the same. So think, what can you change a 4 into, and what can you change a 10 into? And you could totally count multiples of 4. 4, 8, 12, 16, 20, 24, 30, I'm sorry, 24, 28, 32, 36, 40. I count by tens, multiples of 10, 10, 20, 30, 40. So I know that I can change them both into a 40. Oh, wait a minute. I can change them both into a 20 as well. Did I count that wrong? 4, 8, 12, 16, 20. I could change them both into 40, but I think it's always best to choose the least common denominator, which is what mathematicians say, the smallest number. So I could change them both to 40, but I think it probably would be better to change them both so they have a denominator of 20. 4 times 5 equals 20. And if I multiply the bottom by 5, I need to multiply the top by 5. And the one right next door, in order to make a 10 into 20, you have to multiply by 2. And if I multiply the bottom by 2, I better multiply the top by 2. And I can see that they're very close. So let me go ahead and write, it says 2 statements. I did that first side. Oh, I didn't quite read the directions carefully enough. So 5/20. I'm going to change that front side as well. Okay, so 1/4, which is the same as 5/20, is less than, use the same color here, 3/10. And then I can write 3/10 is greater than 1/4. Okay? When you make the denominators the same, you can easily tell which one's bigger. 6/20 is bigger than 5/20. So 3/10 is bigger than 1/4. Rewrite each pair of fractions with a common denominator, then write a statement to compare them. Okay, 2/6 and 3/8. Let's see. 6, 12, 18, 24. I can make them both into 24. So I'm going to take 2/6 and multiply by 4/4. I get 8/24. And then I'm going to take 3/8 and multiply by 3/3 to get 9/24. And I can see that 8/24 is less than 9/24. Letter B, 5/6 and 3/4. I can change those both into a 12, and there's other possibilities, but 12 is probably the easiest. 5/6 times 2/2 equals 10/12. And 3/4 times 3/3 equals 9/12. And 10/12 is greater than 9/12. And the last one, I see a 7 and a 5. I can make them both into 35. I'm going to take 3/7 and multiply by 5/5 to get 15/35. And 2/5 multiply by 7/7. Remember, I'm trying to get the denominator to be 35, which is how I figured out I needed to multiply the bottom by 7. So multiply the top by 7 as well. And we have 15/35 is greater than 14/35. Okay, onto that front page. Let me correct this. Write two statements. I'm going to correct this bottom part here. I think the best way would be to write 2/3, and that's the same as 8/12, so that's less than 3/4, which is 9/12. And then 3/4, it is 9/12, so that's greater than 8/12, greater than 2/3. Okay, I think that looks better and follows the directions a little bit more nicely. Okay, so page 135 and page 136. Okay, remember, if the denominators are not the same, make them the same. All right, kids, see you in class.